Nice, nice lot. So, just at the beginning, just to admit, I think we have today 20 minutes on my time. It's 10 minutes more, Michael. Can we use the last 5 minutes maybe for Q&A? Because I think questions like the one who has been asked maybe occur.
Take your time, Gus.
Yeah, perfect. Thank you. And the question came from brother. I will answer at the end, if that is okay, because I think my presentation will answer already that question. So we will talk about additive today. We will talk about desktop metal, a printing system for mass production. And I'm going to start a little bit talk about me, just let's say introducing me. Most of you know me, but may some of you don't. I'm Demircali. I'm living in Germany, and I was a former SolidCAM employee. I experienced 10 years in SolidCAM, and since the last 5 years, I'm at the additive manufacturing market. We will talk today in my agenda about the history of metal fabrication methods. We will talk about 3D printing, advanced manufacturing technologies, and the market size evolution. AM mass production is a big question mark in the market for a long, long time, and we will today discuss about it, and I will explain you the differences we made with the new technologies of today. And why desktop metal? Why you should choose desktop metal? Let's have a look to the history, because the history tells us always what happened in the past, where we are driving, and what does changed. And if we look to the traditional manufacturing methods we have been using all the years, you see all stay pretty stable, and there are some similarities. So we have the extrusion market, the stamping, powder metallurgy, forging, casting, and CNC. And in the little lines below, you can see the age of these technologies. They're almost, the youngest one is CNC, but most of them are more than 1,000 years away. And that doesn't change. The complexity defines the productivity. When you look, the complexity of your part, if it's increasing, then the productivity goes down. And there is the big question, how we can get a better effect or more output. So a quick shout to the revolutions of industry. We had the fourth revolution, but how we started. We have the steam technologies in the 1780s. We started to have the first mass production 1870. And if you read these lines, you can see that every 100 years, we see a change in the industry and we get a new revolution. The automation came at the 1970s. And today we talk all about connectivity. Also private, by the way. Everybody's connected to everything, and the machines need to be connected. So connectivity is the key in the future to have the, let's say, fulfill the new revolution method of manufacturing. 3D printing is one of the advanced manufacturing technologies, and it is in the news every day. Why? And why it was not that successful? Why we have different styles of machines. We will talk about some of the technologies later, but if you see the first name of 3D printing or additive manufacturing today, it was rapid prototyping. Rapid prototyping because the quality of the part you could produce was never fitting to an end-use part. You couldn't use it for fixtures, tooling. You couldn't use it for an end-use customer part because it was not certified and it was a weak part, almost plastic. We started with FDM and had all these technologies around until we hit the first mold and tooling. Fixtures, we can also add to that. But the amount of parts you can produce with such a printer, high cost invest, and at the end, low output. Not everybody could spend the money, and it doesn't make sense because the market, the bigger market in this world is mass production. You need to have a certain volume. After arriving at a digital manufacturing, which was end use, yeah, it was possible, but not in the right amount. So it was not for the commercial. Personal fabrication is now where we arrived with the new technologies we can use. And I will explain today, step by step, what is the difference. If we look to the market 2018, the size of the market on CNC was even much lower than today and than we expect in the future. That was on the speech of Emil's side, but there are some certain reasons why CNC will grow dramatically in compared to the past. The standard traditional manufacturing technologies, extrusion, stamping, and casting and molding, they are only there because they are super fast, super cheap, and the complexity of the part is designed to be in this range. So you design your parts to get these technologies to use it, but the freedom is limited to these technologies. And there is a little dot, 3D printing, 7.3 billion, 2018. It was one of the smallest dots here. And you see also generative design. I mean, if you today watch the news, you see a new motorcycle, you see crazy parts on it, always generative designed, very crazy structures. That is the future. Why do you see it today? Because that will be the future products. Digital twin, also on ModelWorks, you can see some activities on that side, and the CAD market. So, as I said, the reason for using these technologies is the design, and you design for those technologies. Design defines the creativity, market, sustainability. But on the other side, you need to create also the right production method. Production method cares about the cost, quantity, and lead time. And there is little freedom, but if you can hit the right technology, then you can fulfill both sides and has the maximum freedom. Everybody wants to have maximum freedom. Like with SolidCAM, you can program any part. You don't want to have different software. When we look to the 2030 market in the future, we will see a big change. All these traditional manufacturing methods will go down. They will not disappear. They will just go down from the market size, and CNC will grow. And one of the biggest reasons the CNC will grow is the 3D printing market, because we can hit the speed, a certain level of accuracy on the 3D printing side, and CNC becomes more relevant because the amount of work you do by a part is really limited on the best advantage of a CNC machine, and this is bringing accuracy to the part, having the final finish. And also these days we see the digital twin and generative design market growing in the same amount as we can grow. And this partnership between Desktop Metal and SolidCAM started for this reason. If you look back, the most, let's say, the biggest exhibition in the 3D printing market is Formnext. It's 1 or 2 halls in Frankfurt. If you compare this to our favorite AMB or EMO, it's a much different size. But when I went to my first Formnext exhibition, I saw people there coming from different markets and trying to explain me how to produce a part, coming from a CAM system and working already on machines. And I couldn't understand, how can you teach me? The first 3 questions, he couldn't answer any. So I think the combination of CAM, CNC, and 3D is the right area where we can understand what the customer needs and we can deliver the right solution for them. Because we know, and we would never say you can just print and use it. We will always say if the accuracy allows and it's in the specs. If not, you need to CNC it. So when we look to the additive market, you see a lot of technologies, and I can totally understand that most of people say, that's too much. That's really too much. You have so many variants, and what are they doing? What is the difference? I can tell you one thing, 95% on these all technologies, they are always focused on a single part or a low volume production, because the technology is not ready to do more, or the amount of costs you need to invest is too high at the end. The additive manufacturing technology able to do mass production is binder jetting. We are not reinventing the wheel. It's nothing different than metal injection molding. Instead of pressing some powder into a form, into a mold, we are just adding some liquids to a powder and shape the part and sinter it afterwards. Binder jetting is up to 100 times faster than the existing laser-based solutions. This is not just the marketing thing. The fastest machine Desktop Metal offers today is, in real, 100 times faster. The shop system we are talking about is 10 times faster. We can print 800 cc per hour. Let's talk about the details later. It is an accepted technology. That is the big, let's say, cracking point on this. If you print a part, who's going to certify this technology to your end-use part? That is really a hard game, and it's one of the biggest challenges in this market, because you can't really tell what is this. It is printed, but what is the density and all of that, and is there a certification for it? MIM is a certificated process, and we have the certification for this. So the part you deliver to a customer is from a traditional manufacturing method, but it has been done different. That is the big difference. Open material platform. So if you add a liquid just to a powder, you can use any powder on different machines, different environments, but in general, it's an open material platform. High geometry freedom, of course, as well. We are talking today about additive manufacturing 2.0, and we expect this market growing from 2020, 12 billion to 146 billion in the next years. And does only Desktop Metal do binder jetting? No, of course not. There are many, many companies doing and trying and really focusing on this technology because it's the only one can deliver this fast machining. But on Desktop Metal, we need to admit, we invented this technology. We were the first ones 6 years ago, delivered the first machine. We have the biggest install base worldwide in binder jetting, by far. Most certified materials. It's also important to hit the customer expectations on materials. And the software life sinter. Now we come to the most important point. Life sinter simulates your sintering process. Even the MIM industry and the casting industry has not a solution to really exactly simulate your sintering process. So the parts shrink, so the parts change while sintering, and you need to predefine and predeform your part to get at the end the right result. And that is the game changer on Desktop Metal side. Live sinter, how can we compare that to a product on SolidCAM side? And I found one. It makes totally sense to compare this with iMachining and the technology wizard. Not only that iMachining is one of the best technologies to cut a part in the fastest speed, by the way, it is the best technology, but the easy to use helps the customer to use that technology daily. So it's not everybody sitting in front of a computer and trying to put with iMachining the fastest part in the world. Sometimes they just use it because they can cut their part really, really easy. They just click the buttons and run for it and select maybe a level 1 or 2 in the safety area and get the result. The same happens on Live Sinter as well. In Live Sinter, you can pre-simulate and you press the button, you don't care about the accuracy afterwards because Live Sinter is doing that for you. One big new, again, Apple. Apple is testing using 3D printers for their major manufacturing shift. And if you look at the part shape, it totally makes sense if you could just really print the case, and afterwards there's, of course, some machining. And you can see in the first pictures, you can find in Google, basically, that is binder jetting. Because the parts are 20% bigger on the left side, and in the right down corner, you see the part shrink down to its real size. And if you look on the accuracy, you know, there was also CNC inside. The selected technology is, in this case, binder jetting because of the speed and the amount of parts you can print and the easy to use. From a different angle, most carbon ceramic brakes are made with binder jetting. There are variants of parts we could show, but at the end, the market start to accept this technology, and the speed of those makes sense for it. So there are a lot of products, and I think Jörg explained the most, let's say, suited ones for the CAD/CAM industry, but there is definitely much more than that. And if anybody has a question, I would ask you to go to Michael, to Jörg, or to me today, or also later, to really talk about the variants of technologies. And the growing customer base, of course. We have variants of customers really investing in this technology because of the future will be that.
Gersel, there is one question.
Yes.
What is the difference between rapid prototyping and 3D printing?
3D printing and rapid prototyping, the difference in name is just because it was only for prototyping, not for end use. So they need to call it in the legal side rapid prototyping, because if you say 3D printing, it needs to be an end use part. And that was not guaranteed, and another technology was fitting in the earlier years for the 3D printing. So they renamed it. It's just a renaming, but the meaning behind this is not anymore prototyping.
Now, the second prize goes to Xenia. The answer was a scallop. So Xenia, please come and get your prize. The third question is, what is the option in SolidCAM which lets the user see the schematic position of the tool and part in every step? Again, what is the option in SolidCAM which lets the user see the schematic position of the tool and part in every step? Thank you. Where's Xenia? Xenia?
Gersel answered the question.
You answered correctly.
Why is your technology better than existing? Thank you.
Sure.
Just waiting for Linda.
Sorry.
So there was a question from brother's side. Can this person maybe just raise his hand that I see where the question was coming? Brother. Hi. Did I answer your question? I think it's the mass production makes the change, and the laser-based solutions on the certification basis can't really use, or let's say, deliver the right results to the customers. Linda, was there any other question on your side?
No,
or does somebody have a question?
Okay, thank you, Gersel.
Thank you very much.